All right, so you are going to need your red, blue, and green marker for this. So I'd like you to pick up your red marker. And we see a table of values that needs to be filled out. Exactly like we did just a few minutes ago. So what's weird about the first one? We saw y equals 4x, y equals 2x. We saw y equals x minus 3, x plus 1. This is just what, Tara? Y equals x, right? So that means if I make my x negative 2 and the y is equal to the x, what's my y? It's also negative 2, right? The y value is the same as the x value. They're both the same. Don't do anything with it. Don't multiply it by anything. Don't subtract anything from it. The x and the y are equal. So if x is negative 1, then so is y. If x is 0, so is y. And so on. So you're going to kind of put a little red circle around that because the color coding is going to help us visually today kind of understand these topics. All right. I want you to write next to this thing in red, parent function. Okay? It's an 8th grade word. It's an 8th grade concept, but you start to learn about it in 7th grade. So, pretty big concept here. Now what I'd like to do is have you understand that a table of values creates points on a graph, right? So, in order to graph ordered pairs, you need an x and a y value, right? Well, guess what you just so happen to have? You happen to have 5 pairs of x's and y's. So it's almost like if I make this negative 2, this one would be negative 1, then you have your 0, 0, then your 1, 1, then your 2, 2. A quicker, easy way to do that is to just kind of say, well, they're already sitting there. I'm just going to put a parenthesis around them, and there's my little comma. There's my ordered pairs, right? You do not have to write them out each time, okay? Now, to plot them, because I need to get these all on the graph. Now, you already told me, let's see. You know what? Let's see if you think it's going to be a straight line. Up 1, up 1, up 1, up 1. So if you plot these points and you go to connect them with the ruler and you can't because they're all jaggedy and all mess up, then you did something wrong because these better be a straight line. So let's plot them together. Ready? From the origin is where you start, correct? It's where they originate. So I want you to put your pencil, your red, on the origin. Don't make a point just yet. This negative 2 is in the x spot, so it means I move 2 to the left because it's negative. And then this 2 is in the y spot and it's negative, so I move down. This is plotting points. You learned this in 4th grade, 5th grade, right? Remember you used to connect them and they made pictures and stuff like that? So now I want to plot point negative 1, which means from the origin go 1 to the left and 1 down. 0, 0 is easy. It is the origin. So far, so good. Does it look like I'm on the right track to be a straight line? 1, 1, and 2, 2. Okay? When you connect your dots, I don't want you to just do that. That is not a line. It's a line segment. Okay? It doesn't have any arrows. So I want you to take your lines all the way out to the edges of the box, edges of the graph. And then it's not a line if it doesn't have the arrows, right? Okay? So here's what's really cool about this. You know where lines come from now. Where did this line come from? It came from a table of values that you helped me create. We chose some random x values. I kept them small because I wanted them to fit on this 6x8 grid here. And so what do you think the name of this line is? The name of this line is y equals x. That's the name of that line. It's got a name. It's not Bob. Yes, the name of that line is not Bob, it's y equals x. All right, pick up your blue marker or whatever shade of blue you have. And let's work on completing this table of values in blue. What does that mean? Shh. It means take whatever your x value is and add 2 to it. So if x is negative 2, then y is going to be 0. You got it. If you're at negative 1 and you move 2 to the right, now you're at 1. And then do what? Anybody see a pattern here? Is there a way to keep finishing this table without having to keep going back and doing the substitutions? Austin, what do you think? Yeah, you can just go ahead because you know that this is going up by what? From 0 to 1 is 1. And you know if it's going to be a line, all these have to be the same. So this one, as long as this is going up by 1s, then 2, 3, and 2 more than 2 is 4. Okay? So now I plot these points. This point is negative 2, 0. This is always tricky when one of them is a 0. What does this one tell me to do? From the origin, go 2 to the left. What should I go up or down, though? None. So I'm going to go and land right here, right? Then I'm going to do the negative 1 and the positive 1. And land there. Let's look at this one again. This time the 0's in the x spot, which means I don't go left or right at all, but I do go 2 up. And then 1 to the right and 3 up. And 2 to the right and 4 up. Connect your dots. Hopefully they are straight, because they're supposed to be. All right. What's the name of that line? Yes. The name of this line is y equals x, but plus 2. So, let's see. Because the whole point of doing this activity with these different colors is for you to compare everything to this red line. The red line is always going to be 1, 1, 2, 2, 3, 3, 4, 4. It's always going to be y equaling the x value. It's always going to go through the origin. And it's always just going to go that up 1 over 1, okay? So, what is the relationship between this red line and the blue line? What did the blue line do? It took the red line and it did what to it? Shifted it up 2 units, right? So I used to teach this with an overhead. I had an overhead. You know what overheads are? You probably don't even know. Like, they're clear and you draw on it. So I would draw a line on it and then I moved the overhead up. And then it would lay, so the red line would lay right on top of the blue line. So it shifted up 2. So in other words, didn't you just like take every point here and shift it up 2? Where in your equation is a big ol' hint that tells you to go up 2? The big ol' plus 2. See that? So that plus 2 said, take the y equals x, which is, by the way, your red line, right? And shift it up 2. Take every point and shift it up 2. And you did. And you created a new line called y equals x plus 2. So now I want you to take a look at the green one here. The one that you're going to do in green. And before we start to fill them out, let's make a guess. If the y equals x was right in the middle, and the y equals x plus 2 shifted up to, what do you think the y equals x minus 3 is going to do, Madison? Okay, so I want you to take your pencil, not a pen, not a marker. Just take your pencil and put in a couple really light dots where you think that green line is going to land. And then once you kind of have your educated guess or your hypothesis, we're going to fill that table of values out and we're going to see if you're right. So, let's get to it. Y is equal to whatever the x value is, but minus 3. This time I'm standing at negative 2, and I don't move to the right, I move to the left. So what is negative 2 plus negative 3? Or 3 to the left of negative 2? Negative 5, good. In green, so you're using your green marker right now. Keeping it all organized. What number is 3 to the left of negative 1? Good. At this point, does anybody want to stop and just kind of say, oh, so they keep getting bigger? So what do you think would go next without even having to figure it out? Negative 3. And then negative 2. But do you think we should probably take a look at it? Maybe 3 to the left of 0 is good. 1 minus 3, is the same as 1 plus negative 3. Yeah, that's negative 2. And 2 minus 3 is really 2 plus negative 3, which is negative 1. Okay, so we're good. So now we plot these points, and we see if you're right. You probably were, because you were probably, you just needed that blue line to help you. So let's go negative 2, except this time we're going to go all the way down to negative 5. Then negative 1, negative 4. 0 means don't go left or right. Just go down 3. Now we're at 1, negative 2. And the last one should get you to the line. Is that where you had your pencil marks? Is that what you thought? Okay, so we are going to connect this. Make this our green line. We're going to name that line. The name of this line is what? Yep. Dominic. Yep. So y equals x minus 3. And you know what? It's minus 3. And how did you know it was going to go 3 down? Because it said take that y equals x, which is your red line, and move it down 3. That's all that minus 3 meant. So it took your red line and it shifted it down 3 each point. Got it? So here's what we're going to start to be able to do now that we are familiar with this. I have a really cool, this is the only one, oops. I have a calculator that graphs in color, so it'll show you, here's me in red, I want to graph what y equals x looks like. So we can do on this calculator what it just took us 20 minutes to do on a table, except it just literally does it for you. So then I go back to y equals, and I can put in another line, and I'm going to make this one blue. And this one is going to be my x plus 2, right? So then it should hit right through the plus 2. So then when I go back in and do the y equals x minus 3, you expect it to hit right there, okay? So what would I type, or actually, where would this line go?
1 under the 3.
It won't go 1 under the 3, because it would need to go...
Oh, negative 6.
Yes, yeah, negative 6. So it would go taking that, because look, if I cover all of these up, I have y equals x, y equals x, y equals x, which is that red line. But I'm shifting that line either up or down. Now you tell me, what would I type in to get it to go through positive 5 up there? Through positive 5. I would type in y equals, yeah, x plus 5. Got it? Okay. What did you notice has not changed? What did we talk about? Like the whole first time we talked about slope, what hasn't changed? A lot of the coordinates did change. The tiltiness? The slope, right? All of these lines are the same. All of these hills, if they were hills, they'd all be the same difficulty to walk up, right? Okay? So we haven't changed that yet, but we're going to, but not just yet. So flip in this to page 3. We're going to skip 2 and come back to that, because we have just enough time to do number 3 here. All right, get your red pencil or pen or marker. And I told you we're comparing everything to the parent function, which is as basic as it gets. So we're going to draw that red line again. So if you remembered what you did, you just said that every one of your x and y values were the same because y equaled x, right? Bless you. Do you remember what that looked like when you plot y equals x? It means that there's a line at a point at -2, -2, 1 at -1, -1, 0, 0 right through the origin, 1, 1, 2, 2. So go ahead. And the reason that I have you are doing these every single time we do a discovery is because it all compares to this parent function. Okay? And the name of this is y equals x. Always in red there. So now grab your blue pen. And what do you notice? Looks awfully close to y equals x. There's that little thing in front.
Everything's going to change, like -2, the y is going to be positive.
Good. She said everything on here is going to change. She said the -2 has become a +2, and we call that taking the opposite of, right? Because isn't that another way to say instead of -x, the opposite of x? So listen to what I'm saying before you write anything. The y value is the opposite of the x value. So if the x value is -2, the y value is +2. Good. What's the opposite of 0? Just 0. Can't have a positive or negative 0. The opposite of 1 is? And the opposite of 2? Now, don't plot the points yet. Take a guess. What do you think this is going to do to the line? It's going to kind of mess it up a little bit, but what's it going to do to it?
It's going to make it go negative.
Okay, good. She remembered from last week that we talked about slope. This is a positive slope. She thinks it's going to take it and make it negative. Let's find out. So in blue, let's plot. We go 2 to the left, but this time we don't go 2 down, we go 2 up. All right. We go 1 to the left, but we go 1 up. Looks like she's into something. What? 0, 0 is still through the origin. 1, -1. And 2, -2. So, again, they should all be in a line because this rate of change is constant. It's going down 1, right? Each of these is going down 1. So when I connect this, you almost have like a perfect little X. Okay. So let's talk about what it did. Yeah.
What side would the y equals -x go on?
It doesn't matter. I'm going to put it right here. So when we label this, the name of this equation is y equals -x. Be careful because sometimes it can look like it's your equal sign, part of your equal sign. So what people like to say is that line flipped upside down. But we're going to be in 8th grade, so I want to teach you the correct term. Does anybody have any idea what it's called if I were to just like take this x-axis and fold it on the x-axis? It is symmetrical, yes, but what is the act that I'm doing to this line? If I fold it on the x-axis, do you think that this red line will fall on top of this blue line? Do you think? If I had the patty paper, it would. And then this line, that's called we look in the mirror, we see our reflection. So this folded got reflected over the x-axis. Hey, do you think if I folded it on the y-axis that it would reflect also? Like if I folded it in half on the y-axis, do you think this line would land on this line? Yeah. Okay. So this was reflected over the x and the y-axis. It could look like. Okay. So now what you're going to do is put this away real quick, but you're going to flip the back side of your green sheet, the one that we took the notes on. And we only worked on worksheet number 1 and 3. So we can only answer the question for a couple of these here. So on worksheet 1, I want you to see, without me telling you, what effect did adding a number to or subtracting a number from x have on the graph? I want you to think about that answer. So look at your blue line. What effect did adding a number to that red line do? What did it do to it? Yeah, it shifted it up. So we don't even need to get into the details. I'll write in blue. So adding a number to shifted the line up. It shifted the parent function, that red line up. That y equals x. What did subtracting a number from do? Yeah. And that kind of makes sense, doesn't it? You wouldn't expect it to go down if you put a plus, would you? Let's answer number 4. On worksheet number 3, what effect did making the coefficient in front of x negative? So what effect did putting that little negative sign do to the red line, to the graph? It made it a negative slope. Okay, and we could also say it reflected over the axes. Okay? You could probably answer number 7. And that's probably the only other one you can answer right now. Read it. Get an answer of what you think. Go back to equation worksheet 1 maybe. Tell me what you think the parent function is. You have it written. It's written in red. Parent function is y equals x. Okay?